What is this limit? Limit as n tends towards infinity, 1 plus 1 by n raised to the power n. The moment you see this limit, you immediately shout it is Euler's number, which is approximately 2.71. But did you ever thought that pi can also have a limit definition just like Euler's number? If you thought about this, then this video is for you. And if you did not thought, then again this video is for you, because it will help you to analyze pi more deeply. So generally we are taught that pi is equal to almost 3.14, and it is the ratio of circumference to the diameter. Like this we are taught, okay? But you never come across the actual thing that why pi is 3.14. So to understand this, you have to understand the limit definition of pi, which will help you to analyze pi more deeply and more efficiently. I know you all must have solved many questions in limits chapter in your 12th grade, I guess, or 11th grade. So in that you all must have solved many limits in which you would have got pi as the limiting value, but you must have ignored this, because for you that time it might have felt that this is obvious that the answer is pi, but that was many times referring something related to the definition of pi, the limit definition of pi. So let's understand what is it actually. But for that you should know the concept of regular polygon. What is a regular polygon? A regular polygon is one in which all the sides are equal and all the angles are equal. Interior angles are all equal, okay? But you all must be thinking that suddenly why I am making video on pi, because today is 14th March, and if you don't know, 14th March is celebrated as Pi Day. So that is why I am discussing the real meaning of pi today, the limit definition of pi. So let's understand this now. So suppose there is an n-sided polygon, okay? But I can't draw a n-sided polygon right now, because you will get confused. So first of all, I will take example of a hexagon, a regular hexagon. From there I will move to a n-sided polygon, okay? Suppose this is hexagon, okay? So all of its sides will be equal. So let's zoom it now. Okay. So suppose this is the geometric center of this hexagon. So now consider this portion, this line segment. Okay, this is just for reference. Suppose this length, the side length is x, or if you want, generally you take it as L, so let's take it as L, no issue. And suppose this distance is suppose R, for now just assume it, okay? And this angle as theta. Okay, so you know the value of L. You need to solve for R, maybe, we don't know, maybe. And you have a theta. So how you find theta in terms of number of sides in a regular polygon? Well, if you don't know, theta is 360 degree divided by n, right? Why? Because if you connect, suppose this is the center, if you connect all of these things, I mean these lines over here, all of these vertices at the center, you get 6 different triangles, and all of them are congruent because it is a regular polygon, this is a regular hexagon, okay? Hence, suppose this angle is theta, so this will also theta, this will be also theta, this will also theta, and this will be also theta, and this will be also theta. So 6 theta is equal to 360 So theta is actually 360 by 6, which is 60 degree in this case. But if it was a n-sided polygon, then over here we will get n theta as 360. So theta will be 360 by n, correct? Okay. So now consider just this triangle. And yeah, since all the triangles are congruent, so this length will also be equal to r, right? Okay, because this is r, so this will also r, because it is a regular polygon. Okay, now consider this triangle. So this is a triangle. Okay, so this is r, this is r, this is l, this is theta. I'm writing it over here because I have to draw a bisector over here. I guess it's not looking like a bisector, so just a minute. Suppose I draw it like this. Okay, not exactly, but still you can understand that this is a bisector. Okay, so this is L by 2 and this will be L by 2, correct? This 90 degree angle, because it is an isosceles triangle. So since this is an isosceles triangle, so this and this is equal. So it means that when you draw the perpendicular bisector over here from this angle, it will bisect the angle at theta by 2 and theta by 2, right? Now we have this triangle. So from here we can say sine theta by 2 is equal to L by 2 divided by r. So r just like that. So you got a relation that sine theta by 2 is equal to L by 2r. Okay, where theta is 360 by n. So you can clearly say from here, for an n-sided polygon, this is theta 360 by n. So 180 degree by n, theta by 2. So this is actually sine of 180 degree by n is equal to quantity L by r. Okay, not r by l, it is L by r. Okay, so what? Well, let me erase this and let me explain you all. So we had got sine of 180 by n, 180 degree by n is equal to L by 2r. Okay, L by 2r. Now what is the perimeter of a n-sided polygon? It is equal to n times L, right? So just either you can multiply, let's multiply both sides by n. Okay, so you have n sine theta, sine of 180 degree by n is equal to n L by 2r, correct? Okay, so what? Well, n sine 180 degree by n is perimeter of an n-sided polygon divided by 2r. Okay. Now what if the regular polygon has infinite sides? That is, notice that if it was a square, it was looking like this. If it was a hexagon, it was looking like this. And suppose if it is an octagon, it will look like this, somewhat like this, and so on and so forth. So you can clearly see as the number of sides are increasing, it is tending towards a circle. So limit as n tends towards infinity, n times sine of 180 by n is limit as n tends towards infinity, perimeter of that regular polygon divided by 2r. So what will be r over in that case? So r will be the radius. Okay, so actually this is written as limit as n tends towards infinity, this Pn by 2r is actually the circumference of the circle divided by the diameter. 2r is the diameter, And what is circumference divided diameter? It is equal to pi, right? So this is actually pi. Hence, the actual definition, the limit definition of pi is limit as n tends towards infinity of the quantity n times sine of 180 degree by n. And this is the actual definition of pi. So let me just summarize everything. So to summarize, we started discussion with the question that if Euler's number has a limit definition, then why can't pi have a limit definition? So with that question, we started the discussion with regular polygons. Okay? And in regular polygons, we calculated that the angle in this triangle, this is theta, and theta is actually given as 360 divided by number of sides. Okay, and from here we bisected this. So this was L by 2 and this was L by 2, this was R. So we got sine of theta by 2 is equal to L by 2R. Okay, and then you multiplied by L to get perimeter of nth side of n side polygon, basically divided to R, this distance. Okay, and then you set the limit as n tends towards infinity, and since when the number of sides becomes infinite, the distance between each side, the length of each sides will become 0, almost will become very very close to 0. And why will it tend towards a finite value? I have the answer for it also. Suppose this is a circle, so you can of course draw a polygon outside it, and you can draw a polygon inside it, whatever be it. Okay, so of course the perimeter of the circle will be bounded between the outer polygon and inner polygon. So how can the perimeter as limit as n tends towards infinity of p of n tend toward infinity? No, it's not possible. Why it's not possible? Because we know that the perimeter, the circumference of circle is finite. So the length will become very 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 small as the number of sides are increasing. Okay, so that is the concept over here. So we set limit as n tends towards infinity of the quantity of this limit, and theta was equal to 360 by n, so theta by 2 will be equal to 180 by n. So we end up getting this expression that pi is limit as n tends towards infinity n times sine of 180 by n. And if you plot it also on a calculator, I mean on a graph plotter, probably you can use Desmos or any other app which you want. So in that, if you plot it for n belonging to natural numbers, you will get that this limit is indeed tending towards pi, something nearly 3 pi is nearly what? Pi is approximately 3.14159, right? And how do I remember these digits? Well, if you don't know the beauty of Pi Day, it is celebrated on 14th March at 1:59 p.m. So that is how I remember these things. Okay, from the definition only, from this value of pi only, Pi Day celebrated at 1:59 p.m. on 14th March. Okay, if you don't know this fact. So pi is 3.14159, and that's the limit definition of pi. So I hope so you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. And if you felt that in this video my voice was a bit down, so I was not well, so that is why. Okay, so till then, bye bye, take care, and all the best.